Hey everybody, just wanted to make you a video to help explain all the details of the Module 2 assignment. These are the things I'm going to be looking for. I'm basically going to be using the rubric to grade the assignment. So, if you check all those boxes, you complete all the tasks that involve observing patterns, creating the scatter plot, you complete the task, everything that's associated with analyzing your sample. If you do all that, you should be all set. But I know that when you look at a big list of instructions, it can be kind of confusing, so I just wanted to help with those details. So you can use Microsoft Excel. That works just fine. I think that's what SNHU is going for, and you're probably going to have to use that in later courses. For some people that have Chromebooks, if you're going to use Excel, you're going to have to use a virtual machine. You're going to have to use SNHU's online Excel program. And so the details of that it doesn't look like it's listed here. I think it can operate out of your SNHU email. I guess I'll have to look into that. But what I'm going to do is I'm going to use Google Sheets, because Google Sheets is basically it's really similar to Microsoft Excel with a few subtle differences. Okay, a few differences in how it looks, but the formulas that you type in, the codes that you type in for the formulas are the same. Use the same notation there. So it's really similar. You should be able to do a lot of the same stuff except for creating the scatter. Okay, so I typed in Google Sheets in Google. Access it however you usually do it, but I'm going to go to Google Sheets, open a blank document, and it's a spreadsheet software. It looks similar to Microsoft Excel. There are some functions that are different. I will pull up Excel here to show you how to get the scatter plot, just because I know the buttons are different. But so we need the data set from the project, so I'm going to download the real estate data set. And can I even drag it? No, that doesn't work. Okay, so I'm going to open it. So you can just drag it in here. Okay, and then we've got our data set loaded. So one thing that the project says is you're supposed to pick a region. Okay, I don't know, does it specify what to select the region as? Because a region could be a state, could be a big region like a state. A region could be a county. Oh, nope, sorry, they have a variable categorized as region. So there's east, north, central, there's west, south, central, east, south, central. There's a lot of different regions. So I'm just going to pick one. I'll pick the mountain region. It looks like Arizona, Colorado, that type of area. And then one of your first tasks is to get a simple random sample of 30 pieces of data, so 30 home prices. And let's see, column D is listing price. So, yeah, we're going to want all three of these variables. Let me see. In the project, this is my first time teaching the course, so some of the details I have to go look up to make sure. I think X is going to be our square feet, our predictor is going to be square feet, and Y is going to be the listing price. I don't think we really need this one, but you could obviously get it really quick from dividing dollars per square foot. So dividing the listing price by the square feet. But, okay, so either way, we'll just take all three of these columns with us when we make our calculation. So I chose the mountain region. So if I want to do a simple random sample, what I actually want to do to make my life easier is I'm gonna click the very first cell for the mountain region, the top left cell. I'm gonna scroll down. I'm gonna hold Shift. And I'm going to click the bottom right cell to highlight all the data that I want to take with me. Okay. There's other ways of doing it, but it's actually going to just take longer. To get my region and just have that data, I'm going to highlight that region. I'm going to right-click the highlighted region, click Copy. And then down here in Sheets, and same thing in Excel, you can add a new sheet and then paste that data in. Okay, so now we have our data separated for us to look at for a little bit. So take your region, put it in a new spreadsheet, a new sheet inside your Excel file. And then what you want to do to randomize, I guess there's other ways of doing it, but what is probably quickest is just to find an empty cell next to the end of your data, type equals, rand, open and close the parentheses, hit enter. Okay, and that's a random number between 0 and 1. And so you can click the checkbox in Google Sheets, or if you're in Excel, you can just click and drag to put random numbers next to every single row that you have in your data set. Because when you click and drag, what Excel does, what Google Sheets does, is it repeats that formula. So I just told my Sheets file to randomly create numbers next to all of our rows. Okay, and then now this is how we're going to select our random sample. Let's sort by that random number. Let's click column G at the top. If you right click, you go down to sort sheet A to Z, or least to greatest. I don't think it shows up in the right click in Excel. I think what you have to do in Excel is it's something about searching here. I'll start pulling up Microsoft Excel to highlight the differences. Google Sheets is just a little quicker because it works right in your web browser, but I mean, some people's computers are faster than mine, I guess. But either way, you want to sort the sheet from least to greatest, or from greatest to least. Either one is fine. Doesn't matter which one. Because when you do that, what you just did is you sorted your data set based on a randomly generated number. So now the order has been completely switched up here. Okay, and what you might notice is that, hey, your numbers aren't least to greatest or greatest to least. It's because every time you do something in Excel, or in Google Sheets, it's programmed to randomize a new set of numbers. Okay, so we're done with that. It's done our job. We sort it least to greatest based on those random numbers. You can get rid of them if they're annoying you. Okay, and then what we can do for our project is we can take the first 30 numbers in our randomized list and just delete everything else. Now we've completed the first step. We have our randomized numbers. Okay? So we picked a region. We got a simple random sample of 30. And then we were asked to calculate the mean, the median, the standard deviation for that sample. So I'm just going to put some titles here for the numbers that I'm about to calculate. And to do that, to calculate the mean, you type equals, calculate the mean, median, standard deviation for that sample. Let's see. Of listing price and the square foot variables. Okay, so we need to do mean list price. We're calculating a median list price, and we're calculating a standard deviation list price. And then we also need to calculate a mean square footage. We need to calculate a median square footage. And we need to calculate standard deviation of square footage. Okay, because the assignment says report the mean, median, standard deviation for the list price and the square foot variables. So to calculate a mean, you type in equals average, open parentheses, and then you could click and drag if you want. So this is my list price column, $390,000 for that house. I could never get that. And then close the parentheses, and that's your mean list price. Okay, the mean square footage, type in the same thing, equals average, same thing in Excel too. Open parentheses, click and drag the list price data, and close the parentheses. Now you have the mean square footage for those homes. Median is a similar operation. You type equals median, open parentheses, and then the programmatic way of doing it is typing D1 colon D30. That's a different way of doing the same thing. That says give me the median for every number including D1 and between D1 and D30 inclusive in both the endpoints there. So the same thing as clicking and dragging. So I type equals. Actually, I'm going to leave this just in case somebody else picks the mountain region. That way I'm not giving away answers. But for the standard deviation, type in equals stdev.s, open a parentheses, and then we want it for D1 to D30. That's the standard deviation of the list price. Notice that I typed in stdev.s, and if you see in Excel and Google Sheets, it'll say .p. You don't want that one because we don't have population data. We don't have the list price for every home. We have the list price for our sample. We have just a sample from these areas. So most of the time, it's very rare that you'd want stdev.p, okay? stdev.s, because the whole point of doing statistics is we want to make an estimation based on the population. If we could go out and ask everyone, hey, what's your blood pressure, then we don't have to do any sort of interpretation. We know the true average blood pressure in America. Okay, but the problem is we can't go out and get everybody. By the time we've gathered all that data, somebody's died, somebody's moved into our age category. So we have to use a sample. So almost always you're going to want stdv.s. Okay, so that's calculating the mean, median, and standard deviation. That's how to do that. So I'll leave this part to you. Discuss how the regional sample is created is or is not reflective of the national market. I mean, I guess I can't walk away without saying something. Look, if you were to calculate the mean, let's see. If you went to my state of Maine and calculate the mean amount of rainfall for the year, you wouldn't tell somebody that's thinking of moving to the United States, hey, the mean rainfall in the entire United States is, I don't know, 0.05 inches per day. I don't know what it is in Maine. But you wouldn't say that to them, right? Because that's what it is for Maine. That's not what it is for the entire population of states in the United States. So that's a huge part of statistics, is that you don't take a sample and assume it applies to everybody else unless you can justify and say that your sample really represents the entire population. Okay, if you did a really good job, made sure you got every type of person on the face of the human earth to be in your sample, and you sampled them in sufficient size, then maybe you can say, hey, this result applies to everybody. But that's a really big thing in statistics. Don't try to say your example applies to everything else. Okay, that's all I'll say about that. But so I'll leave you to do the analysis. You're supposed to generate a scatter plot. I'll show you how to do it in Google Sheets, and I'll show you how to do it in Excel. On Google Sheets, let's insert and chart. And instead of a column chart, we want it to be a scattered plot. And the x-axis, let's see, we want that to be, can I just click here? The x-axis, we want to be the predictor variable, which needs to be, and this is something I've got to look for, okay? You need to make sure you put square footage on the x-axis. Here's a better way of doing it. We're going to insert a scatter plot in just a second, okay? But what we should do is we should tell Excel what we want to have for data before we do that, okay? We should tell Google Sheets, we want this column, and then I'm going to hold Control on my keyboard and click this column to highlight both of those columns. And now let's try inserting a chart again. I think it's going to, wow, that's wrong. Okay, I've tried to do a line chart. We want a scatter plot. And there's our scatter plot. But look, there's a crucial problem with my scatter plot. There's a convention in mathematics that the independent variable is always on the x-axis. That way, when we look at something, we immediately know, okay, the x-axis, the thing that's making the prediction is the x-axis. If we don't do it that way, then we're going to always have to make some extra interpretation. It takes longer to interpret a scatter plot instead of just being able to look at it and know what they're talking about. So in short, the x variable needs to be on the x-axis. The one that's doing the prediction, the independent variable, needs to be on the x-axis. The variable that's not being changed by the other variable. Look, when you think about the two variables we have a home price and we have a square footage. Which one predicts the other? Does a price change how big the house is? Like, you don't go out and say, my house is $400,000. I better add on 500 square feet, right? It's the other way around. My house is 2,500 square feet. I think, wait, is that a lot? That seems like a lot. Yeah. You wouldn't say my house is 2,500. You would say my house is 2,500 square feet. I can charge more for it. So square footage is predicting housing price. So we need square footage to be on the x-axis. So I'm going to click that and select this option. And then look, it's a straight line because I'm only plotting the x variable right now. I need to also change the y variable to be $390,200. So there's our plot. We've got it now, okay? So let's do that in Google Sheets before we go on. You can skip ahead in the video, not Google Sheets, in Excel. You can skip ahead if you're not going to use Excel, if you're going to stick with Google Sheets. Just copied and pasted my data. You would just normally just double click this to open it up after you've downloaded it from SNHU. Let's go to insert. And really there should be a header up here. I think Google Sheets was actually taking my variables and thinking that. Oh, come on, don't give me a hard time. I'm just copying and pasting and moving here. I'm going to delete this, move it back over once I have a header. Yeah, okay. So I'm going to click this, copy, paste it over here, and now I can have headers for each of mine. This is the area. I don't know if that was. I think those are cities. That part doesn't really matter. This is home price. This is square feet. Okay, so same type of thing. You want to select the data that you're trying to make a scatter plot for. So I'm going to click this one, control click this one, just like I did in the last one. And then Excel, it's usually a button right here. If it's, yeah, I think you click insert and it's always going to be a little icon that you can click. So there's your scatter plot. So really similar, it's still the insert button. Check it out though, the x-axis right now is home price. We said that needs to be reversed. So to change that in Excel, okay, so to change the x and y axis, you want to right click the chart, click change, select data, let's edit, and then we want to switch the x and y values. So this is the code for what are the x values. So I'm going to copy that, and I have a notepad off to the side, and I'm pasting it there so I don't lose it, okay? And then I'm going to copy the y values, so I can control C, or you can right click copy, and then you want to paste that in where the x values go. And then go grab the code that you had for the x values and put it in for the y values. And now it's switched. Now we've got just what we want. Square footage on the x-axis, price on the y-axis. So it's doing what it's supposed to do. Okay, so next thing on the assignment is we needed a trend line. Let me see if I can remember how to do that. I thought it was insert. Okay, so click chart design. You want to add a chart element to get the trend line. And then there's a trend line option. Look, these are all non-linear, okay? Well, this is linear forecasting, but what you want is a linear trend line, okay? So there's your trend line. And then to figure out what the equation is, the slope-intercept form equation, yeah, it's like slope-intercept form, the least squares regression equation. Let's see, I think we got to click the trend line. Yeah, if you click the trend line over here, on the right side of the screen, you see Format Trend Line. There should be a button to display the actual trend line. Yeah, so if you click this bar, I don't know why it's a bar graph here, but you want to click that, scroll down. You want Display Equation on Chart. And there's your y equals mx plus b equation, the slope-intercept form equation that we need. Okay, to get that equation in Excel, in Google Sheets, I keep messing up those names, don't I? I don't know if it's super easy to do it in Google Sheets. It's real quick to type in the code though, okay? You want a slope and you want a y-intercept for a least squares regression equation, right? So the slope type equals slope, and then the order is important. The y variable has to go first. So I'm going to click my y variable. I'm going to click that column, put a comma, and then click the x variable. It's got to go y variable first, x variable second with a comma separating them. So there's that slope we just saw in Excel. In the y-intercept, you type equals intercept, open parentheses, y variable, comma, x variable. And so there's your equation. Y equals the slope, 107.068, x plus 151,977.47. The slope and the y-intercept that we needed. Okay, we got the mean, median, and standard deviation. We did that. Create the scatter plot. I think we've got the big details here. We've generated the scatter plot in 2 different programs. We've got the pattern. So I'll leave the discussion of a pattern to you based on what we've done in our readings. Do you see a pattern here? Are there any outliers? Let me know if you have any questions about what that means. This part here says if you had a 1,800 square foot house based on the regression equation, what price would you predict it to be? All that means is that x equals 1,800. So you just go in this equation and solve it by plugging in 1,800 in for x. Okay, and so there's just a quick little bit of calculation to do there. I would just do 107.068 times 1,800 plus 151,977.47. So there's my prediction. I predict a home price of $344,700 roughly. Okay, so that's how you can use a regression equation to make some predictions. That gives you the average value. Okay, the average value of a house, that's 1,800 square feet, is whatever that number was that we just got. Okay, so I think that's everything. I know it's a super long video, but hopefully that covers all the big stuff. There's still some interpretation that's left there for you to do. Trying to think if there's anything else to say. One thing to say about this 1,800, if for some reason your data set doesn't have 1,800, if your data set only has homes that are from between 2,000 and 2,500 square feet, then you would only predict for 1,800 with caution. Okay, because to predict for that is to do something called extrapolation. You're trying to make a prediction outside your data set, so that would be risky. Okay. Yeah, so just message me, i.raymond@snhu.edu. If you have questions, I'll be happy to try and help you out.